This is Geometry, Chapter 2, Section 3, Biconditionals. Alright, so we've talked already about a conditional, an if-then statement, converse, inverse, contrapositive. We have another one that's called a biconditional. And a biconditional is a statement that's that's true if the conditional is true and the converse is true. When the conditional is true and the converse is true, then we have a biconditional. And it's not in the form of if-then, it's in the form of if and only if. If and only if. So biconditional, when the conditional is true, when the converse is true, then it's called a biconditional, and it is in the form of if and only if, and it has a symbol. Before we had the one arrow, the biconditional has two arrows. So P, if and only if Q. P, if and only if Q. So here is an example that they give. Here's the conditional. If, so this is two angles have equal measure, then the angles are congruent. Two angles have equal measure, then the angles are congruent. The converse of that would be if two angles are congruent, then they have equal measure. So in this case, the conditional is true, has a true truth value, and the converse is also true. Because if something is congruent, then they're equal, right? If something is equal, then they're congruent. So if you switch the hypothesis and conclusions, they are both true. That gives me a biconditional. So when I write this as a biconditional, it would be two angles have equal measure, if and only if the two angles are equal. I mean, if only if the angles are congruent. Two angles have equal measure if and only if the angles are congruent. Again, it's in the simple P if and only if. So the arrow both ways, Q. All right. For got it number 2, they give us a biconditional, and they want us to break it up into their 2 conditionals. So they have 2 numbers are reciprocals if only if their product is 1. So the conditional that would be the conditional would be if 2 numbers are reciprocals, then their product is 1. And then the converse would be if their product is 1, then 2 numbers are reciprocal. All right. So when I use the word reversible, uh, when I use the word reversible, so it's not really an if-then statement, it's just a definition. And in this case, we have a definition that says, so this is example 1, a straight angle is an angle that it measures 100 degrees. So a straight angle is an angle that measures 180 degrees. All right, that's that guy. If it's reversible, it's almost like switching the hypotenuse and conclusion. It's after the verb. So in this case, the verb is. So we would switch that. An angle that measures 180 degrees is a straight angle. Since it's reversible, then we can make this a biconditional. So it's a straight angle is an angle if and only if it measures 180 degrees. So we could write that as a biconditional, a straight angle and we could write like this. an angle is straight if and only if it measures 100 degrees. 180 degrees. Okay. Differentiated between good definitions and bad definitions is if you can prove it by giving it a counter example. So here's a definition. A square is a figure with 4 right angles. If you can reverse it, then it would be considered a good definition. So here's why this can be considered not a good definition. It says a square is a figure with 4 right angles. This is true, right? A square, definition of a square is it's a parallelogram with opposite sides being of equal length, that is, has 4 90-degree angles. Yay. However, if I was to reverse this statement, can I still say that it's true? A figure with 4 right angles can I think of a figure that has 4 right angles and is not a square? And that is, yes, you can, and that figure would be a rectangle. A rectangle has 4 right angles and is not a square, so this is false. So when I reverse the statement, it's false. So since it's false, this is considered not a good definition. And it's not a good definition because it's not reversible. It is not reversible. Therefore, not a good definition. I can think of a counterexample to it. Okay, so that's this section, I believe. I hope you have a great rest of your day.